I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, IARE, Hyderabad. Now, we are going to discuss about how we can blink an LED. So, before going to the LED blinking, up to now we discussed about different types of core components, memory devices. Okay. Next, we are going to discuss about input devices and output devices. Among the output devices, we are discussing about LED, how we can blink an LED. First, input devices. So, with respect to changes in the input environment, the output will be changed. So, for capturing the current input information, we require different types of input devices. Those are maybe input devices. What it will do? It will capture the current information. So, which type of devices we are using here? We can use sensors. What is sensor? Sensor is a transducer which converts physical changes in the information into the electronic signal. Example, microphone. What it will do? Based on the pressure applied on the vocal cords, it will generate some sound signal. This sound signal is converting into the electronic signal, corresponding electronic signal. Okay, that is microphone. Next, temperature sensor. What it will do? It will measure the current room temperature, whatever may be. Suppose if you want to keep the sensor in the body, it will take the body temperature. Or if you want to measure the room temperature in case of air conditioners, it will measure the current room temperature. Okay, like that. And we can use keypad. To give the input information, or touch screen. Or push buttons, push to talk, example. Next, switches. Like this, we can use different input devices for capturing the current status of particular parameter, either temperature, either pressure, either sound signal, like that. Next, output devices. What it will do? It will monitor the particular parameter and control that parameter. Suppose, if any person comes nearer to the door, the sensor continuously monitor some area, particular area. In that area, if any person comes nearer to the door, it will capture that the person is coming or not. If he is coming towards the door, means it will open the door by using actuator. Example, actuator. What it will do, actuator? Actuator converts the electronic signal into the physical changes in the environment or particular parameter, means open the door. open the door. Lock the wheel. Open the airbags. Like that. That is actuator. Next, for monitoring purpose, we can use different display devices. Like in the beginning days, we are using CRT display, cathode ray tube display. In our laboratories, we are using CROs to monitor the amplification, rectification, like that. Clipping, clamping. For various operations, we are monitoring what is going on in the particular parameter. Signal is amplified or not? Signal is rectified or not? Any ripples are there in the response? That will be monitored in the cathode ray tube display. Later, we are using LCD display. Next, we are using LED display in hospitals to monitor the patient heartbeat or particular parameters. We are using these display devices. Or in any four-wheeler, we are using dashboard to find out the wheel pressure or backside any person are there, unknown persons are there, like that. So, output devices are used to monitoring and controlling the environment or parameters or information. So we will check one of the devices, LED. So LED means light emitting diode. So it is one of the PN junction diode. By default, the LED is in off condition. Whenever we are giving the input voltage greater than the conducting voltage, the LED will be on. So by default, it is in off condition. That value is represented as 0. Whenever we are giving the input voltage greater than the conducting voltage, the LED becomes on. That binary value is 1. So my requirement is, by default, when I switch on the LED will be on. Off means, switch off means LED will be off in general. In some cases, at particular condition only, the LED needs to be on, or at particular condition only, the LED needs to be off. So at that time, that when the LED needs to be on, when the LED needs to be off, that is defined in the form of instructions. That instructions depends on the core component which are used in that design. Suppose I want to blink this LED on 8051 microcontroller. I want to control this LED blinking operation by using 8051 core component. Okay, I can use any one of the processing element, either 8086 or 8051 or variants of 8051, like that. Suppose I am considering 8051 variation, that is 8089S52. I am taking this processing element. Here it contains 32 input and output pins. These are classified into 4 ports: port 0, port 1, port 2, port 3. So I am taking this 8089S52 development board. Okay, this development board. In that, it contains 8 LEDs. The 8 LEDs are 0, 1, 2, 3, 4, 5, 6, 7. Total 8 LEDs. I want to blink particular LED. Suppose I want to blink only this 0th position LED. So LED off means 0, on means 1. Okay. So by using in this development board, I want to blink this LED based on with some 250 milliseconds delay or 10 milliseconds delay, with some delay. Okay. How we can design, that will be discussed now. I am taking port 0. In that I want to blink 0th LED. So initially the LED is in off condition, that is port 0 means equal to 0x. Off means all LEDs are 0. Initially, I have turned off all LEDs. So corresponding hexadecimal value is 4 zeros means 0, 4 zeros means 0. This is binary representation. This is hexadecimal representation. So in the program, I am giving hexadecimal value. So port 0 equal to 0, 0 in the initial condition. Later, I want to switch on port 0, 0th LED. So at that time, that LED will be 1. Remaining all will be off. So I am giving 0 to the remaining LEDs. So means this hexadecimal value is here 1, here 0. Means I am giving port 0 equal to 0x01. Again, I want to give some delay. That is delay of some 10 milliseconds. Again, I want to switch on this LED. And again, I am giving port 0 equal to 0 to switch off that one. And again, I am giving delay. This loop will be repeated number of times. That will be discussed here. So first here, initially, the LED will be in off condition. For that, I am giving 0. You know, already discussed how we are giving 0, 0. Why we are giving 0, 0. Later here, I want to switch on all LEDs. Suppose 0, 1, 2, 3, 4, 5, 6, 7. Total 8 LEDs. I am taking port 0. Initially, all LEDs will be off condition. Off means that binary value we are giving 0 to that LED. So we are taking port 0 here. Corresponding hexadecimal value is 0, 0. So I am giving 0, 0 here. Later, I want to switch on all LEDs. Switch on means the LED needs to be given 1. So 1, 1, 1, 1. Like this, I am giving 1 to all LEDs. So what is corresponding hexadecimal value? 4 ones means this is binary representation. In hexadecimal, that value is F. In hexadecimal, this is binary representation. So that is 1F. Again, this 4 1 is 1F. Okay. So like this, I am switch on the all LEDs. So after switch on, I want to switch on this LEDs up to 10 milliseconds. So I am taking some 10 milliseconds delay. Here, each digit indicating 1 millisecond. So I am taking 1 millisecond delay that will be defined in the loop here. Okay. Again, after 10 milliseconds, I want to switch off all LEDs. So I am giving 0. So here we are getting 0, 0. Okay. I am giving 0, 0. Again, the LEDs switch off in 10 milliseconds. Okay. Again, that's why I am giving 10 milliseconds. So here, the delay function is defined outside here. So delay of some variable. So whatever the value I am taking, that is taking from this iTime variable. Since that value is integer value, I am taking integer. So unsigned integer, because there is no negative values. Again, one variable indicating 1 millisecond how many clock cycle will be taking. Like that, second variable indicating how many clock cycles required for each milliseconds. First variable is for how many milliseconds. Second variable for each milliseconds how many clock cycles we are taking here. Okay, like this. So like that we are defining the delay function. Then the same functionality will be repeated infinite number of times. That's why I am taking loop here while of 1. So 1 means always true. So this function is repeated infinite number of times. So like this, I am blinking port 8 LEDs Alternatively, at a time 8 LEDs will be on, and it is on in 10 milliseconds delay. 10 milliseconds will be on condition. After 10 milliseconds, again all LEDs will be off, and these LEDs are in off condition up to 10 milliseconds. The same functionality will be repeated infinite times. So like this, I am interfacing this 8 LEDs with the 89S52 development board. Now we are going to discuss about 7 segment display. So whatever the content I want to display, that will be displayed in the 7 segment display. So 7 segment display is an electronic display for displaying letters and digits. So generally this is also light emitting diode. So it will display either visible or invisible. Suppose if you are considering normal LEDs, that will be visible LED light, infrared light. In case of TV remotes or any remote controllers, that is invisible light. Okay. If you look at any LED, here 7 segment means total each segment. So this is first segment, this is second segment, this is third segment, fourth segment, fifth segment, sixth segment, seventh segment. So we are using 7 LEDs here to display the digits, either decimal digits or letters like 0, 1, 2 up to 9. Similarly, A, B, C, D, F. To display the digits and letters, we are using this 7 segment display. Here 7 LEDs are there. That's why we are calling 7 segment display. So each we are assigning one variable for each segment or each LED based on the value you want to display. That we will discuss here. So the number 8 is displayed when the power is on to all segments. And if you switch off that middle one, we will switch off that one. We will check this one. Suppose this is 7 segment display. We are assigning one variable for each segment. Suppose I want to display 1, I am switch on only B and C. If I want to switch on 2, means A, B, D, E, G. I want to switch on 3. I want to display 3. At that time, I am switch on A, B, C, D, G. If I want to display 4, corresponding variables B, C, F, G. If I want to display 5, six, 7, 8, 9, A, B, C, D, E, F, like this. So based on the information I want to display, I want to switch on that LED. Switch on means that LED value needs to be given as 1. Remaining LED's value is 0. See the truth table? Here, if I want to display 0 means accept 0. 0. Accept G, remaining all 1. 1. So based on the information I want to display, I am giving the values 1 for that LEDs, remaining are 0. So therefore, Boolean expressions for each decimal digit that requires respective LEDs are on or off. So it displays 0 to 9, A to F. So this will be controlled by using processing element based on the instruction we are giving here. So there are two types of configurations. One is common anode display, common cathode display. So here common anode means all anode of the each diodes are connecting together, and common cathode means all cathodes are connected together. So in common cathode, 7 segment displays, all the cathode connections of LED segments are connected together to logic 0 or ground, whereas logic 1 through current limiting resistor to the forward bias, the individual terminal A to Z. Okay, similarly, in common anode connection, all LEDs are connected to the logic 1 in common anode, logic 0 connected to the ground. So like this, we can display the desired information in the 7 segment display.
Like, share and subscribe. Hit the bell icon for more updates.